Hey, what's up, guys? This is Chung here again. So this time, today's daily challenge problem number 164, maximum gap. Um, this one is pretty classic problem. Okay, so you're given like integer array enums, right? So you just need to return the maximum difference between two successive elements in its sorted form, right? And if this array contains less than two elements, return 0. Okay, and so you must return an algorithm that runs in linear time and uses a linear extra space, right? I mean, a brute force way, we simply just sort, right? Sort it, and then we just check each neighbor element, and then we get the maximum. But obviously, with a sort, it's going to be an unlog n time complexity. But this one, it asks us to do a linear, which is O of n, right? So to be able to solve this one in O of n time complexity, we have to use some other like concept, which is the bucket. So how can we utilize the bucket for to solve this one in the O of n time complexity? So here is how it works. So assuming we have a minimum and we have max, okay. So this is the total. So this is the total difference, right? I mean, if we do a max minus minimum, right? So we have a total difference. Total difference, right? And if we divide this one by the number of the gaps, which is n minus 1, okay? Because we have n numbers, right? And we have n minus 1 difference, right? Because that's two different values, right? So if we do a total difference divided by n minus 1, we'll get like what? We'll get like a bucket size. We have bucket size. So why will we need to create buckets? Okay. So with the bucket size, we have several buckets. Each bucket will have the same size, right? So the reason we want to create those buckets is because after creating those buckets, we can put those numbers into those buckets, right? Based on because this one's going to be from the smallest to the biggest. Let's say the smallest is 3, the biggest is 100, right? So basically we can have like a different bucket size. Maybe this one to 20, 24, this one 24 to 21, 21 plus 24, which is 40, 45, and then here 45 to 66, something like this, right? So because the bucket, the total, the max is the end, and the minimum is the start. So based on this kind of bucket, we can put each number inside a bucket. Okay. And I think this one is like inclusive. This one is exclusive, maybe 20, 25, 64, 46, something like this, right? And one fact is that the biggest difference, the maximum difference cannot happen inside a bucket. So it means that let's say there are like 3 numbers in one of the buckets. We have num1, num2, and num3. So after sorting these 3 buckets, after sorting all the numbers in this bucket, the maximum difference cannot be inside of these buckets. So the reason being is that since we have already like divided the total difference to n minus 1 buckets, right? And if inside of the bucket, if we have such 2 numbers whose maximum difference is greater than the bucket size. Actually, because since the size of the bucket is this one, right? So it means that any two numbers inside a bucket, the difference will be smaller than this one. Will be smaller than this bucket size, right? And based on this kind of a pigeonhole principle, right? I mean, so it has to be a gap, right? Whose value is either equal or greater than this bucket size, right? Because the bucket size is the total difference divided by the n minus one, right? So if the biggest one, let's say if the maximum difference is smaller than this bucket size, then what's going to happen, right? So if the smallest one is smaller than this thing here, then if we do a if we times n minus one, right, and then the total difference will be smaller than this max and minimum, which beats the purpose of the bucket, right? So which means that there has to be a number, right? I mean, basically it means that the maximum difference has to be exist between the buckets, not inside the bucket, right? Because again, right? So inside the bucket, because the biggest difference inside the bucket can only be smaller than this one because it's bounded by the size of the bucket, right? So in order to get like a size, in order to get like a bucket size, sorry, in order to get a difference who is either uh, equal or greater than this kind of than this difference, we have to look between the buckets. Okay, and when we look between the buckets, so how can we look between the buckets? Actually, all we care is what? Since we are only looking at the successive numbers, elements, right? Basically, those two numbers has to be next to each other. So between two buckets, so the difference between the two buckets will be the maximum number from the previous bucket and the minimum number from the next bucket, right? So the difference between the buckets will be the minimum from the buckets I minus 1, subtract the maximum from the bucket I. So which means that, for each of the buckets, all we need to maintain is the minimum and the maximum value among all the numbers in that bucket. And when we have those like two values for each bucket, we can simply loop through all the buckets, and then we just get the numbers, the difference between the buckets, and we just get the maximum among all of them, right? Because like I said, the only possible maximum difference can only happen between buckets because the way we created the buckets, we use this average. We use this kind of we use like this kind of double slash division, right? I mean, if this division basically if this n minus one cannot be divided by the total, right? Basically, the bucket will be a little bit smaller than the average, right? That's why the size, right? I mean the difference inside the buckets can only be smaller. Can only be smaller than this maximum difference. Yeah. And so with that being said, I guess we can start coding. And we have minimum equals to minimum of numbers, and maximum equals to max numbers, right? And then we have n is going to be the length of numbers, okay? And basically, if the n is smaller than 2, right, we simply return 0 because we know that, right? And then we have bucket size. Bucket size is going to be the maximum, right, minus minimum. and then divided by n minus 1, right? That's the size of the bucket. So again, right, so the reason we use this one is that, we create each bucket so that, any two numbers inside this bucket, the difference cannot be greater than the maximum difference. Right? Because, because like I said, because in total we have n minus 1 gaps, right? In total we have n minus 1 gaps, and yeah, I think I'm repeating myself. So, but here we have like another things we have to be careful. This has to be a maximum of 1 between 1, because if the maximum and the minimum they are the same, right? And then for example, you have 3, 3, 3, right? This kind of stuff, here, instead of 0, right? Because 0 divided by 2 will be 0. We need to at least one bucket. That's why we need to have like a maximum 1 here. And for the buckets, I will use a dictionary, I think. So the value will be the list. So the reason I use a dictionary is because not every bucket will have some numbers. That's why I'm only maintaining this kind of minimum maximum for the bucket who has some numbers in it, right? And this list, it means that list is like this. It's the maximum. It's the maximum and the minimum. Basically, the first element in this bucket, in this list, will be the maximum, the current max, and the second one is the current minimum. Okay. And so we just need to loop through the nums in nums, okay? And then we just need to get the index or the key of the bucket, right? Let's get a key. The key will be what? We do a num minus minimum, right? And then we divide it by the bucket size. So that's how we get the key or the index of the bucket. Okay. And so since we need to maintain these two things here, so if not bucket key, so nothing there, we simply do this one, right? Key of num and num. So at the beginning, minimum and max are the same if there's only one number. Else we just need to update that accordingly, right? So the maximum is going to be the maximum of bucket key dot 0, right? And then number. Similarly for the minimum, right? Minimum of bucket key of 1, right? In this case, right? And then num here. Okay, cool. So now after this for loop here, we have already get all the minimum and the maximum in all the buckets here. And now I just need to loop through the buckets, because here, let's say we have three like different buckets here, so it could be only we have some numbers in here, and in here. So in these two buckets, there's no numbers in it. That's why uh, in this case, even though we're supposed to have like 5 buckets, but in this bucket dictionary, instead of 5, we only have 3 elements, because in those 2 will be empty. So that's why when we calculate the difference, right, we need to loop through the elements inside the buckets, right? So so the way I do it is like this. So basically, I'm maintaining like a previous key, and so for key in sorted, right? In sorted bucket dot keys. Okay. So every time I update the key, right? And then if the pre key is not empty, sorry, it's not -1, I update the answer, right? This one is going to be a max answer dot bucket key. So the current one, current one is the minimum, which is the index 1, and subtract the maximum from the previous bucket, which is the pre-key of 0, right? And then I return the answer. Right, so here the reason I don't use index is because the previous one may not be the key minus 1, right? So if I run the code, submit, yeah, so it passed, right? Yeah, so as you guys can see here, so this time, the time complexity is just O of n, because we have n bucket, right? And then we do a for loop to place each number inside a bucket, and then we update the minimum, the maximum, and then second for loop is just to calculate the difference between the buckets. Okay, so one last time, right? I mean, just to recap this problem, right? I mean, the key thing for this problem is that how can we create the bucket size? So we use the maximum minus minimum and divide it by n minus 1 to create bucket size. So again, the reason being is that, let's say the minimum is 3, right? And the maximum is 18. And the size, let's say the n is equal to 4, right? So the bucket size we have is what? The bucket size we have is 15 divided by 3, which is 5, right? So why we use this 5 as a bucket size? So now the bucket, we're gonna have like we'll have like 3 buckets, right? It's gonna be this one, and this one. So at the beginning we have 3, right? And then at the end we have 18. So what's the first one? So it's 1 to 3. So it's not. It's 3 to 7, and then we have 8 to 12. And then we have 13. 13 to 18, I think. Yeah, but notice here, actually, so the last bracket, so the last bucket is a exception, because for the previous bucket the size is like 4, right? And the last one is 5. So I mean, so when I say the maximum difference cannot exist inside one bucket, it does not include the last one, because let's say we have n is equal to 4, right? So let's the 4 numbers 3, 8, 13, and 18, right? So 3 will be inside here, will be inside the first bucket, and 8 will be inside the second bucket. But both 13 and 18, they'll all be inside the last bucket. So in this case, the max difference is what? The max difference is 5, because actually they are equally, they're all 5. In this case, this one, so the max difference does exist in the last bracket, but this is a special case, because with this case actually we can also get 5 from the previous 2 buckets. Okay, so just keep that in mind. So this is like a bit corner case, right? And so that's the only corner case. For the others, let's say it's 3, 9, and then also 13, right? 13 and 18. In this case, right? So as you guys can see, the biggest difference is 6 here, right? It's between the first and second buckets. Now you guys can see, right? So because the biggest difference can happen inside a bucket, excluding the last one, is 4 instead of 5, right? So which means that the maximum difference has to be between the buckets. Otherwise, if it's inside if it's inside a bucket, the maximum we can get inside a bucket is 4, right? So 4 times n minus 1 is what? It's, it's 12, right? It's 12. It's not 15. That's why we divide create buckets in with this size. Yeah, I think I already repeated too many times for this problem. Yeah, hope you guys understand what I'm trying to say. But anyway, I'll just stop here. Thank you for watching this video, guys, and stay tuned. See you guys soon. Bye bye.